Good afternoon, everyone. Welcome to our session on understanding continuous dimensions and discrete measures. My name is Laura Record. I've been with Tableau as a trainer for 2 years. Prior to that, I spent 12 years working with SAP until I could not resist the lure of Tableau and decided to change careers and come work here because it is so cool. Before we go any further, I want to introduce you to Ed, and in the back, he's running the audio, and he's fantastic. We've got Joel, who is our room assistant. He's doing a great job. He's waving to all of you, but you can't see. And then Tyler's running around handling all of the AV equipment. So thank you to all of them, because without them, this would not work, and you could never hear us. I'll go ahead and turn it over to Christy. She'll introduce herself, and then we'll go ahead and get started.
Okay, thanks, Laura. So I'm Christy. Like Laura, I'm also a Tableau trainer. I teach all 3 of the desktop classes as well as visual analytics. And this is a topic that we cover in every single one of our classes, regardless of level. So just to get an idea in this room, how many of you have been using Tableau for less than a month? Okay, how many of you have been using Tableau for less than 3 months? 6 months? A year? 2 years? 3 years? 5 years? Okay, sorry, I'm always interested in that because discrete and continuous is something that we talk about all the time. It's in Tableau, it's obvious, it's there, but there's so much confusion around it. It's one of those concepts that until you just kind of get in and get where it's coming from, it holds you back in a lot of other areas. So in this section, we're starting from the bottom. So we're going to start from the absolute basics about discrete and continuous, and exactly what it means to be a dimension and a measure. How is that different from discrete and continuous? From there, we'll move on to talking about dates, because dates are kind of a special beast in how they work with discrete and continuous and dimension and measure. So understanding how all 4 of those concepts play in with the dates. From there, I'll switch it back over to Laura, where we'll talk about some more advanced features. So how do these things impact path mapping? How does it affect our table calculations? Hex bin mapping, all of these different things where using a continuous dimension sometimes makes more sense than using a continuous measure or a discrete dimension. So a number of different topics. Again, we're starting from the very bottom just to make sure we're all on the same page and the same language. As I said, Laura and I teach this all the time. As trainers, we're used to people talking back to us. So if you have questions, if something's not making sense, if you're like, you know, we've beaten this part to death, let us know so that we can make sure that we're giving you guys everything you need. Okay? So as questions come up, please feel free to bring those up. And with that, I'm going to go ahead and start us into our first section where we're talking about dimensions and measures versus discrete and continuous. Okay? So as I said, the absolute basics are where we're going to start. And we're specifically using the Superstore data because we want to make sure that this is data that is comfortable and familiar to absolutely everyone. So let me get my data selection into Superstore. All right. No, that is not Superstore. There are no flights in Superstore. There we go. That is the Superstore we know and love. So first, easy, simple question. Where are the dimensions, where are the measures? Up is dimensions, bottom is measures, okay? Blue is not dimensions, green is not measures. That's the first most basic part. The dimensions are those things that can slice and dice our data, basically, whereas the measures are those things that we do math on. So I want you to notice a couple things as we pull these out. If I just start with something like our subcategory, and I pull that on out to rows, because it is a dimension, it goes out to the database, it finds all the unique values and brings those back. That is what it means to be a dimension. When I go to the data source, give me the unique values. Measures are the opposite. When we have a measure and we take and pull that out and place that up on columns, we're aggregating. So by definition, if I am a measure, I am doing math on it. I am aggregating it up to the level of detail in the view, period. That is the absolute difference between measure and dimension. There is nothing else. Good on that so far? Okay. So when we have measures and dimensions and we pull those out, what we're doing is with each dimension, we change the level of detail of the view. So if I pull out category, and there's 3 categories, all of my measures will aggregate up and give me 3 results of those equations. The average of profit, for example, per category. I bring out subcategory, I've got 17 of those. So now we're going to get 17 average profits. That level of detail in the view is going to change. So if we watch as we pull each of these different fields out, so I'm going to go ahead and grab my, let's do segment, place that up on columns. We'll notice down in this bottom left corner where it says 51 marks. That's telling me how many unique combinations of all my dimensions there are. So there are 51 unique combinations of my segments and my subcategories. That means I am getting 51 different sums of profits. If I add all of those together, I would get the same result as if I pulled these dimensions out and I have just that one profit value right here. Okay? That's it. Dimension and measure. Good so far? Okay. Like I said, starting with the basics. Discrete and continuous are completely different from that. They are not the same as dimension and measure. Dimensions default to being discrete. That means when I pull a dimension out, by default it is blue. That is just what it is doing as a default behavior. But I can change that on my dimensions. My measures are the same way in that they have a default. When I drag profit and drop that on out on my columns, most of my measures by default are green, meaning they're continuous. You'll notice when I bring a continuous field out, I get an axis. So anytime I place a continuous field on rows or columns, that's giving me a spectrum, a continuous axis. But I can change that. So for me, discrete and continuous make the most sense in this context. Think about weighing something or measuring something. You go to the doctor's office, he's got that scale with the bars across the top. He moves the little slider on over and tells you where your weight is. But he's got to move that along that scale, and your weight is where it lines up, where it balances. You step onto a digital scale, and it gives you a printed readout, just that plain number. Okay? That's the difference between discrete and continuous in a nutshell. Continuous information is on that slider, it's on that scale. We have a spectrum, and we're finding out where we intersect with that spectrum. So when I say something is continuous, I will always get that axis. And so if I were to measure something like coffee, we see where it hits against that axis, and that tells us how much we have. If we have a different beverage, we can, whoops, not left click. We can measure that out and see that lemonade, we've got 8 ounces. I see where it hits that axis. Same thing as sliding that scale on weight. Discrete, on the other hand, is just going to give us the display. We don't have to move that slider up and down the scale to see where it hits. Instead, we can just select whatever it is we're looking at. In this case, I'll say flour, and we're going to get that readout. Okay? We don't know how far that scale goes above it or below it. It's just giving us that readout. Good? Okay. So let's play with this a little bit and see some of the differences. So if I switch back on over to my dimensions and measures, right now my sum of profit is green, which means it is yes. If I use my little drop down, I can tell it, hey, let's make that discrete instead. Because it's a measure, it's aggregating. I'm going to get the sum of profit. But if I switch this over to discrete, it's still, let me click it and not squeal at you. There we go. It still gives us that sum of profit. I'm still getting that aggregated information, but now I get the label, like the digital readout on that scale. So I can take other fields like my category dimension, and now I'm getting that readout for every single different profit value. It's still aggregating that up, giving me the sum of profit. Good? Benefit here is I can now take other measures. Let's say that I was most concerned about my sales value, and if I bring that out as a continuous measure, when I drop it on columns, I get the bars showing me my sales value, but this profit information is summed up discretely. I don't have a bar for it, I just get that label, just that readout. Good so far? Okay. So let's take it a little bit further. What we've done so far is we've taken a measure and made it discrete. So I've said I just want the label, I don't need that axis listed across the bottom. I also want to take a moment for us to see a little bit of the differences that happen when I use these values on things like color. If I place sum of profit on color, notice I'm getting a separate color. That's because it is discrete. I've said, give me the label, give me the readout. I get a separate value for every single one of those. If I take and change this so it's continuous instead, there's my axis. There's my scale. I'm fading from light blue or dark blue to light blue. So I've got that spectrum. That has to do with whether it's discrete or continuous. I still only have the same 3 sum of profit values underneath this, but now they're on a spectrum rather than being just those individual labels listed out. Okay? So that's our measure. If we switch that on over and use it as a discrete or a continuous field, and I'm going to go ahead and pull that on out of my view because I want to switch this up just a little bit, pull sales out as well, and I want to understand a little bit more about the subcategories that I have in my data. How many subcategories do I have in technology? Yes, excellent. Glad I didn't do product. There'd be like 7,000. Yeah, so we can look and see I have 4, but because this is a dimension, I can see every single unique value for those subcategories. I see what those 4 are. They come back from my database with all the unique values. Even though it's a dimension, I can take and I can switch this on over and make it a measure instead. So I might want to count the distinct subcategories that I have. Now, I'm going to move that on up to column. And when I place that up on column, I now have that dimension that's being used as a scale. So I'm counting how many there are. I've got that measure, so it's counting how many, it's aggregating that data, and I can see how many subcategories there are. Why do I have more than 4 in technology? What was that? Non-unique. I'm doing just a count. So I'm counting every row that has one of my subcategories within technology. If I switch that over and I do a count distinct, now I'm counting the unique names underneath. So those 4, instead of listing them out and splitting the data, I'm just saying how many there are. It's a measure. I'm aggregating that information. Good? Okay. So that's how we can take our dimensions and turn them into measures. We can do a limited number of things on our text measures. We can count them. You'll notice we've got a very small number of different choices underneath our measure option. Okay? So that's the start where I can switch those measures on over. I'm going to go ahead and pull this on out again, and we're going to switch this up one more time because I want us to take a look at our discount information. So those of you who have played with our orders, Superstore data, have you found any issues with discounts? Anyone? No? Anybody familiar with the tables in the East question? No? Oh my goodness. All right, if you see people walking around with a t-shirt that says tables in the East, those are people who have dug into the data, and it's kind of an inside joke at Tableau. I will let you in on it now. We have to do a little test as we're learning the product. It's called our bronze demo. And you have to demonstrate product knowledge and dig in and understand what's wrong with tables in the East. The problems with tables in the East is they're all unprofitable. And they're unprofitable because tables in the East are discounted at about 85%. Okay? Not necessarily the best business plan, but a good data problem to play with. Not all the Superstore data has this same problem, but we're going to use that discount field to explore it a little bit and understand this discrete and continuous there as well. So if I take my discount out and drag that, like click on that and drag it on out to my rows, it's a measure. I'm getting my average discount. I can see what the average discount in my data set is, which in this case, 15.6. Okay? But that doesn't tell me if I have a lot of things offered at 1% and a ton of things offered at 85%. I don't see the spread. I don't see where those different values exist. And I can't tell if I'm profitable at one discount level or another. So if I want to divide my profit information up, divide my transactions up by something like discount to find out how it impacts other things, it makes sense to treat it as a dimension. Instead of aggregating it, I want to get all my unique values back, switch it over to a dimension, and now I can see all of the unique profit values that I have. But remember, green means continuous. So right now we're still on that spectrum. So I've still got that scale of information. So it's being treated as a dimension. I'm getting my unique values back, but if I switch and display it discretely, now I see all the unique discount values, and I can tell I've got something going on right up there at 80%. So that's every individual discount that's been offered in my data set. Okay? Notice also up here on rows, it's blue, and it doesn't say sum, it doesn't say average. So when you don't see that aggregation to the right of the field, that's another one of those signs this isn't a measure. This is being used as a dimension. Okay? So if I go ahead and take my profit information out, and let's see if I can use the mouse better than the touchpad. The answer is yes. And I drop that up on columns, I can now tell that I have serious profit issues as I move down anywhere above that 30% discount. Good so far? Okay. Now, I also want you to notice how my discounts jump. I go from 0 to 10%, then 10 to 15, then 15 to 20. And as we keep going, I've got this little motion right there at 32%. So we're not getting exact amounts between each of these. I've got some gaps where I'm jumping faster in one spot than another. But with these discrete values, we're just seeing the unique values. They're in order, and I can rearrange them. I could decide I wanted to move one of these values up to the top. We can't do that when we're on a spectrum. We can't move these around. They have to stay in that linear order. But with it discrete, I can change and sort by whatever field that I want. Now watch what happens when I take this dimension and make it continuous. Now, we probably don't want the line here. Tableau's on automatic, so it's saying, oh, you've got two continuous fields out here. You likely want to use a line. In this case, Tableau did not predict exactly what I was after, so I'm going to switch this over to a bar. And let's go ahead and adjust these down so I've got those narrow bars. And I want you to notice that now I'm on this continuous spectrum. So the space between 0 and 10 is equal to the space between 10 and 20 and 20 and 30. So I can see these bars being really close together, that I have two different discounts that are offered between 30 and 32%. So I'm on that continuous spectrum. I can't sort anymore. This is one long string, but I can see the distance between, the gaps between those values. Good? Okay. So again, this is just, oh yes sir, go for it.
I don't understand how you got the equal. Does it just make it?
How I got the equal.
Well, they're equal distances.
Yeah. So the question was not understanding how I got the equal distances between these. That is what it means in Tableau to be on that scale. Like the scale that you have at the doctor's office, those marks between pounds are exactly the same space because we know that if I'm halfway between them, that's 5. So just by definition, the scale is going to give us that equal distance between all of my markers.
Can you adjust that?
Absolutely. So if I want to change how this lays out, I can right-click and edit that axis. And from here, I could go through and tell it, you know, let's go ahead and get that mark every, let's do 0.05. So every 5 percentage points. So I can adjust that. They'll always be equal, but I can change which ones show and how many of them there are. Okay? And with my discrete, I was able to drag these around. With it being continuous, I don't have that option. So we'll talk more in a little bit about how some of this really impacts us in some of our more advanced features, because getting this core concept makes a huge difference in just about everything that you do when you start getting into things like mapping and hex bins, data densification or spark lines, path mapping especially. Whether you have a continuous field or a dimension is going to change how it behaves, but it always follows those rules we just covered. Dimensions are separate and unique. It comes back from the data as separate rows, so we're breaking the data down further. Measures always aggregate. They're not going to change how many rows you have. They're just going to do math on whatever value you have underneath that. Okay? Discrete's just going to show the actual values. It's that label. It's that readout. Continuous has that full bar spectrum where it's telling you where it's hitting on that spectrum. Okay? So that's the basic of discrete and continuous. So just to do a very brief review of a few of these, I can use one of my dimensions as a measure. So in this case, if we count those distinct products, so I've got my product information located right over here. We can go through and count how many of those there are, the distinct number of products in each category, so that dimension becomes a measure. If I go over to my measures, I can take something like that average discount, and I might want to really focus in on my profit, but I'm curious about how that average discount is impacting that profit. So I can list it as text, as some secondary information. It's not the primary focus of my visualization, but now it's there as some backup. Okay, and that's the discrete measure. And then we can take our measures like that discount information, and by using it as a dimension, we get the unique discounts back from the database. I get separate rows for each of these, and I can roll another measure up and see how it's impacted as my discounts change. So that's it. Dates are no different. The one difference with dates is we can break them down a little bit differently because they exist well in both worlds. So if we continue on and dive into dates, I want to pause here and see if there's any other questions over that first piece that we just looked at. Feel good? Okay. All right, so diving into dates. As I said, dates, no different. They follow the same rules, but dates can be a little bit more complicated. So we're going to start off by talking about date parts and date values. Raise your hand if you have struggled with dates and that's why you're here. Okay, a lot of hands on that. Yeah, that's one of the big things that catches people out in Tableau is that dates are powerful. There is a lot of information stored in every single date. And so they do a lot in Tableau, but understanding the why or the what behind it can be a bit of a challenge. So I'm going to start, again, switching back to that Superstore data, where we're going to grab that order date information. And if I just click and drag it on out, discrete or continuous? Yes, it's blue. That's discrete. Perfect. Now, I'm going to teach you a trick you may or may not know, but it is my favorite thing with dates. How many of you right-click and drag your dates in? Okay, the rest of you will from here on out. If you right-click a date and drag it on in, instead of giving you the default, which is always a discrete year date part, it lets you pick. Okay? The parts across the top right here, those are your exact dates. So that's saying whatever's in that row, give me that exact date. And you can do that either discretely or continuously. We'll talk about that in a second. Below that, we have all of these blue fields. And we typically hear people talk about a date being discrete or a date being continuous. But I want to separate those concepts out for a moment from date part and date value. Okay? Today is, checking my clock, November 8th, 2016. What is the date of the month? What's the day of the month? The 8th. What's the month? What's the year? Those are date parts. We don't care what else is in that date field. We're just saying wherever those slashes happen, ignore them. Just look at a year. Just look at a month. Just look at a day. Those are our date parts, and that is what we see across the top. Like dimensions, they typically get used discretely. That does not mean we have to, but that means that is their default. So these are our date parts across the top, where they hack off the rest of that date and say, I just care about the month. So if I click and use my discrete date part of that month and click OK, I've ignored everything else on the date field in that order date. I'm just pulling back the month information. And if I take and look at my sales value for those different months, we can see that our sales values are a lot higher in November and December than in, say, February. My data for every single year is inside of these. So I've got within this one bar all of the years of my data. And if I place order date on color, you can see those dates, the years are broken down inside. So since these are date parts, I'm getting buckets that are holding all of every year's information, every day's information for those months. And I'm going to pull year off. Notice that in this particular case, it's blue. It's displayed discretely. If I click on this down arrow, I have the option to change it to continuous. So I can take that date part and make it continuous. My bars didn't change, but notice those 12 months, those 12 date parts are now on an axis. So I'm getting a bar for the value in every month. So if I had undone this, or if I undo this, I can sort these discrete values, and now I can see, I'm not in linear order anymore, what my largest to my smallest months are. The moment I change that over and make it continuous, Tableau says, no, 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 no. We start with January, we go to December. That is how time runs. We're going forward. So I have it on a spectrum, I have it continuously. If I'd had any months that were skipped, So if I came back and in here got rid of December, so let's exclude that, you can't tell on discrete. We're just skipping over it. But the moment I take and switch this on over to continuous, now I can see that lack of data. Because on that spectrum, we don't skip September, we just don't have data for it. Okay? Pulling this filter off, so I'm going to remove that filter so we bring that year back. I'm going to make one more switch. So I'm going to pull this month information off, and this time I'm going to bring my order date in. Oh, got to right-click. Right-click and bring that order date in. Underneath our discrete date parts, we have our different measures where we can count them. So I can use my dates as a measure. How many are there where we had sales in a given year? Below that are my continuous dates. Okay? We hear these often as continuous. They are date values. My date parts ignore everything else in that list. My date value says, I care whether or not that January is in 2014. I care whether or not my January is 2016. So we default those to continuous because we're paying attention to that time spectrum. And if I take and do a continuous month, when I click on OK, now I have all of those months. So instead of just getting 12, I'm getting months within every individual year. I've got a timeline. I can't sort it. It goes in order of time. Okay? Those are my date values. Again, they default to continuous, but I can switch and make those discrete. So now each one can be moved, can be sorted. I can put them in order of largest to smallest. If there's any time that I don't have values, it can skip right over those. Okay? So last bit before I turn this over to Laura. Yes, sir?
What if you didn't want to skip over?
What if you didn't want to skip over them? You also have the option. So in this case, I can go through and exclude a few individual time periods. So I can go ahead and exclude those. I have the option when my data is displayed discretely that I can show missing values. So in this case, I can go through and say, I want to see that gap. They're still discrete, but I can see the spaces between. Okay? I could still sort them, but I can see those gaps as well. Yes?
Can you just quickly say what the right-click drag means one more time?
Yes, right-click drag happens on any field or works on any field, but if you right-click and drag in, you get the option to pick underneath the different ways that it can display. So if I don't do this on a date, if I do this on sales instead, we know in this case sales is defaulting to sum, but with my right-click drag, I get to tell it which aggregation I want to use. So I don't have to drop it and then pick. So that right-click drag on dates is the same thing as if I dragged it up here and then selected either a date part or a date value. Okay? So again, those date parts are dividing out those buckets. The date values are looking at it on the timeline. Yes, sir?
So on your previous example, you changed it from discrete to continuous, and it changed the months from alphanumeric to numbers.
Yes.
So can you make that alphanumeric on the
Yes. So the question was, when I went through and I changed this over to be a date part, so if I switch this to that month, in this particular case, I've got the alphabetic information across the bottom. So it's telling me what those months are. But when I take and change this on over and make it continuous, I get those numeric values instead. So we have a date name function, just to let y'all know. If you ever use date part, but you're wanting the alphabetic information, use the date name function instead. But you can also right-click, and if we format this axis, we've got the option to change how things are displayed so that we can alter how that shows. Okay? All right.
Thank you.
No problem. And there's a question in the back. Yes, sir?
Yeah, you may have said this before, so I apologize, but when you have a date up in one of your shelves and you right-click on it to amend the way it's shown, right?
Uh-huh.
It's month, year, day, whatever. There's a top portion
Yes.
and there's a bottom portion.
No problem. Nope. I didn't go into this specifically on this view. When I did the right-click and drag, that top portion were our date parts. The bottom portion were our date values. Same thing here. So the question was, what's the difference between the top and bottom section in this view? You'll notice over on the right, this is your visual cue telling you these are parts of my date. There's no context that May is within a year. So we've just got those parts. It ignores the rest. The bottom section, those are my date values. So that's saying on a timeline, in the context of time for this data, what is the value at the month level or the year level? So it brings in all of those date parts that are above it as well. By default, my date parts are discrete and my date values are continuous, but I can swap either one of those.
Can I follow up on that?
Uh-huh.
On the top part, if I'm not mistaken, is a custom.
Yeah.
Yeah, and if you go into that, right, you can get down to month and year.
Yes.
And in the bottom part, there's already a month and year.
Yes.
What is the difference between those two?
Glad you asked. So these date parts are exactly the same thing as that top portion where it's saying, give me the date parts. So let me do one of these real quick. And sorry, the question was, what was the difference between the date parts here, where I've got month, day, year, or I've got this other piece across the top. So if I do a month here and leave it as a date part, when I click OK, actually that's what I already had. Hold on just a second. Let me pull this on out. And let's drag that order date on up. And I'm going to use this drop down to come in and change this on over to a month date part. I click OK, and I'm getting just the month. It's ignoring the rest. It's the month date part. If I switch this on over and come over to custom, and I do that same month, but do it as a date value, now it's putting it on that timeline. It's putting that on that scale. Take that same thing if I come back into this custom and I switch this back to a date part, but this time I'm going to do month year. So I'm going to do the month part of date year and I click OK. Notice right here, I said date part defaults to discrete. If I go back in and go and change this custom value one more time, and notice right here, I don't have the option to switch that over to date value here. Okay? Because if I did month right here and date value, that's the same thing. So what these are doing is they're giving you the option to quickly do a discrete one, get those discrete fields in the context of time. They're still buckets. It won't be on a continuous timeline. I could have accomplished the same thing by starting off with that continuous month and then going through and saying, hey, let's go ahead and make this discrete instead. So there's a number of different ways to get to that same spot.
This may have shown on the drop-down we had, and I understand the breaking up the parts of the year. Going the other way, you wanted to say first quarter, is that
Mm-hmm. So the question was about quarters, and to make sure I understand, you're wondering about how quarters get displayed? So I just chose a discrete quarter. Yeah, no problem. Nope, no problem. Yeah, so we can pick quarters. That's considered one of those date parts. No problem. And yes. Can't quite hear you. For that, you can always go in. So let me go ahead and I'm going to switch this over to our continuous month where I have it fully spelled out. You can click on that axis or click on that header, and if you go in and format it, over here on the left, you have the option to change how that displays. So you can even customize it and put it in whatever order you want. Okay? All right, so just to wrap this one up, so I can hand this over to Laura and we can start exploring some more fun stuff with this discrete and continuous. When we do the continuous dates, again, we have that full timeline, and I've got that trend line in the background. So that trend line goes all the way through. It's a continuous timeline. I have one trend line that goes all the way across. But I can take and break that up with a discrete field. I can tell it stop and start as these dates change. So when I bop that discrete year up in front of that continuous month, now my trend lines are specific to that year. I've told them to stop and restart. This same functionality has huge implications on your table calculations. So you can change how things like your window averages or your window min and max or totals work. Laura's going to go into that into a bit more detail. But also, my big thing on dates, one of the charts that I always use is this. When we use our discrete fields, we can break these apart, and you end up with the ability to see patterns very clearly and very cleanly that you can't when you're looking at it linearly. So one of the views that I always use when I'm exploring my data is to take these discrete date parts out, and that's going to allow you to kind of mix and match how that information gets displayed, and you can drill down at different levels and see different patterns that the up and down on that line might not make as obvious. Okay? So I'm going to turn this over to Laura so she can move into some of our more fun advanced things that are impacted heavily by this discrete and continuous.
All right. I know you probably all have a lot of questions still about continuous and discrete dates. Don't worry, for those of you who've been using Tableau for less than 6 or 8 months, maybe 9 months, it took me about that long to really kind of integrate discrete and continuous in terms of dates. Right, so it does take some getting used to because there are not many other BI tools that treat dates this way. What we're talking about now are some more advanced use cases for the technology that you've just seen, this simple swap between continuous and discrete. We may not have time to talk about all of these, but all of these will be in the final TWIBEX that you will have available for download. Right? And you will know how to reach us. You should have our email addresses and my Twitter handle, which I look at once per week during Tableau conference. Right? But you'll be able to reach us if you have questions on any of this. The first thing I want to show you ties in very nicely to, oh, this makes me sad, to discrete and continuous dates. We are having a little problem with our internet connection, so I would love to have you pretend that what we are looking at is a map of the Atlantic Basin. Right, all right, there we go. So, maps can be a little bit slow to redraw when we've got this many people hitting the same wireless connection all the time. What we're looking at is hurricane data over time. So we have 2004 through 2014, and we see the path that each named storm took through the Atlantic Basin. To build this, let me move over here. There we go. To build this, we first start by building our map. So we'll bring out latitude and longitude. And that's going to go out and think about a map. And the next thing that I want to bring out is the name of each storm. And I'll drop that onto color. Tableau gives you a warning. You've got a lot of storms here. Are you sure you want to add all those? And I'll say yes, and we get a really pretty scatter plot, essentially, located out over the ocean. So my next step is to filter this by year. So I will select our simple discrete year filter. And right now, I'll just look at 2014 data. I will be nice to my user, though, and show that filter so we can interact with it later. But I'm going to make this a single value dropdown just to save some space. The next thing I want to do is show all of the different time points where we tracked data for each storm. To do this, I will bring out our time field. And I'll drag that time field with a right click and drag onto detail. And I'll start with my discrete day. So I get a lot of dots. And if you look at the color for each of these dots, you can kind of tell the path. Has anyone played the Connect the Dots game when you were a kid? That's what we're going to have Tableau do next. Has anyone worked with path mapping in Tableau? A couple of people. To get path mapping, to get Tableau to draw a line between each of the dots, I need to change this to a line mark type. Notice I have this blank spot on my marks card. That's what you get. The shape button will appear there for a scatter plot. Or maybe the angle button if you're doing a pie chart, because we even give some tab love to pie charts. When I pick a line, Tableau gives me the path button. Now, Tableau does not know the order in which to draw my lines between all my dots until I add something to my path. So we're close to where we want to be. But remember, this is our discrete day data. So if I have a storm that begins on January 31st and ends on February 1st, if we are using discrete data, Which number comes first, 1 or 31? 1. So it's going to draw the mark for February 1st first. And then it will draw the mark for January 31st because it's looking at the discrete day data. Watch what happens to the path of my storm when I change my date value to be a continuous day. Now it's drawing the marks in order along linear time. Any questions on this? Yes? No? No questions? You were just excited about it? Yeah. This is a really nice application of discrete versus continuous dates. Yes? Yeah, I clicked the drop-down on the date field that's on the path button, and I selected the continuous day value instead of the original discrete day value. That's the only thing that I changed.
And the original discrete day value is displaying how the difference different?
It's aggregating the data by the discrete date part. So if we think about the number of days in a month, what's the maximum number of discrete days that we will ever show in a view? 31. But what's the maximum number of days in a single continuous year? 366 if it's a leap year, right? So discrete data is always aggregating at that discrete date part. So we look only at the numeric value and then aggregate all of the values inside of that single date part. Continuous data puts your time in a linear fashion, and we start at the beginning of time and we end at the end. And unless you have a time machine, you can't go back in time in Tableau. Yes? Yeah, so the question is, when you add a date field into your view, Tableau defaults to discrete. Have you all seen that? Yeah, we had to pick something, so we picked discrete. If you want a date to always default to continuous, build yourself a custom date. And you do that here on the data pane. And when I create a custom date, sorry, getting a little feedback. On the data pane, I'll do continuous years. So date value in the custom date field is continuous years. Now, if I hover over that field, it's green. So this is a continuous date field. And if I add that field into my view, it will always default to continuous. All right, our next use case for switching between continuous and discretes is spark lines. Has anyone used a spark line? A couple of people. A spark line is nothing more than a line chart that's been compressed heavily and has all of its tick marks removed. They're not necessarily used for in-depth analysis, but they're great for some quick comparative analysis, looking at trends, things like that. But there are times where we need to see some specific values in addition to that overall trend line. To make these, see, I have category, and then month and sum of sales. I will look at my data by a continuous month first. So click and drag my order date, and I'll select a continuous month. And then I will drag out my sum of sales as a continuous measure. There's my line. I will break this down, though, by category. So category is here in our product hierarchy. To make a spark line, all you do is you make your lines really short. We'll make those much shorter. And you do not show the header of the axis. We'll make these maybe not that short. Let's try that. Oh, that's a little better. And we might make this narrower. And we also hide the horizontal axis just by deselecting Show Header. So those are my spark lines. But what about my sales value? Right? I can do this with a calculation. The calculated field that we're using here is our total sales calculation. And this is a table calculation. So we're saying, look at the sum of sales for each of our categories and give us the total sum of sales. When we add this calculated field into our view, What if I wanted to put it in front of category? Have any of you run into this where you try and put a measure in front of your dimension and you can't? Do you know why? It's continuous, and Tableau requires that all of your continuous values be at the end of the rows and column shelf. Discrete values can be at the beginning, continuous is at the end. So I want to see not this straight line that gives us always the same total sales value as a line. I want to show this as a discrete value. And that will give us the text of the total sales. We can continue along and show the minimum and the maximum along each spark line if we needed to see the variance or something like that. But just that simple change from continuous to discrete means we're still aggregating our data, but we are then not placing that data on an axis. Any questions on toggling these options? Yes?
So, using your very handy tip, so continuous values have to be at the end of the shelf. Is the converse true? Do discrete have to be at the beginning?
Always. You will always see blue fields followed by green fields. So always discrete followed by continuous. And the reasoning behind that is how Tableau structures our data. Our continuous fields are the fields that build our axes. So we need to build an axis first before we look at how to break down data on that axis. So we have to tell Tableau where to look to find the axis information. If we don't have an axis, we're just going to give you the discrete values. Yes, back in the back. Yeah, so the question is this true across the board? Is discrete always first and continuous always second? Because we see discrete first on rows and columns, and then if we're modifying our date partitioning, we see discrete first. We try really hard to keep it that way because we want to make our user interface a little easier for you to work through. So yeah, I can't think of an instance where we show continuous first. Even if you create a custom date, your options at the bottom, the date part, which is discrete, comes first, and the date value, which is continuous, comes second. Any other questions? All right, the next application of this, we're going to look now at continuous dimensions. Have any of you wanted to do Pareto analysis? Have any of you heard of a Pareto chart? Tried to build one in desktop? Did you succeed? Yeah. These actually, once you understand what's going on with discrete and continuous, these are much easier to build. They involve table calculations, so I'm going to go through these fairly quickly. We don't have a lot of time to really dig into the table calculation piece itself. If you have questions about table calculations or the specific calcs that we use in this view, hit us up after class. There are also some additional sessions that you can take during the week that will make you table calculation Jedis by the end of the week. So this is one application, and the 80-20 rule just says that 80% of your output is caused by 20% of your input. Right? So 80% of your profit is driven by 20% of your customers. In this case, we are looking at data from New York City. Anyone here from New York City? Right? Okay, sometimes we get some folks. But this is from people calling New York City services to make complaints. Not an emergency service line, but basically a complaint line. So we want to know what are the 20% of complaints that make up 80% of our volume is what we're looking for in this chart. To do this, we'll use number of records on rows. Are any of you using number of records regularly in your analysis? If you are not, try it. It's magic. All the time. In fact, number of records is the first thing I look at in any data set. Right? It tells you a number of things about the data. It is incredibly useful, and that's what we're using here. And we're looking at this by complaint type. So now I've got my bar chart. I'll sort this, and I'll set this to look at the entire view. So we see all of our complaints here. We just might not see labels for all of them because we don't like our mark labels to overlap. Right? That's not pretty, and we don't like that. The next thing I'm going to do is drag a copy of complaint down to detail on the marks card. Are you all familiar with the control, click, and drag functionality? All right, this is a critical piece of making your Tableau life easier. Let me undo. Hold down the control or the command button, depending on your operating system. This is not us, this is your operating system. Hold down the button. Then click and drag your field. I cannot zoom in while I've got all these buttons pressed. Can you all see the tiny little plus sign next to my mouse cursor? That is your operating system telling you it will copy the object you're dragging. If I let go of the control button, the control key, bless you, I lose the plus sign. I will move this object. Press control and I will copy. So I will control, click, and drag complaint type to detail on the marks card to have a copy of it sitting there. And now we're going to add our table calculations. The first thing we're going to do is make a running total of our complaints, because that's what a Pareto shows us. That's what gives us that nice curve. So I will add a table calculation that is a running total, and I'm going to compute this using my complaint type. So I'm getting a running total of all of my complaints. And then I will add a secondary calculation. That secondary calculation is a percent of total, and that's what converts our running total into a percent axis. And now I can go to my analytics pane and drag out a constant reference line at 0.8, and I see 0.80%. I see 80%. So this is where the bulk of our complaint volume is happening. What I need to know now is which complaint types are contributing the most to that 80% of our complaints. To do that, we have to build an axis on our complaint types. This is where we're going to now aggregate our complaint types. And we're doing the same aggregation that Christy showed you earlier, the distinct count of complaints. We are looking for all of those distinct values. So this will be a measure with a count distinct. Now this looks a little odd until we apply the same table calculation that we applied to number of records. This is first a running total, running along our complaint type, and then we'll add the secondary calculation, percent of total, to turn that axis into a percent axis. The final step, change it to a line. Now on my Analytics tab, I will add a constant reference line to my number of records axis. Oh, the wrong axis. There we go, complaint type axis at 20%. And here, if I look closely, I can see that it's actually only 15% of my complaint types are giving me 80% of my call volume. Yes? It's a reference line. It's a constant reference line. You can also apply those by right-clicking on an axis, always an axis, and then adding a reference line. Play around with these options. This is a fantastic way to benchmark your data. We had a question in the front and then in the back. Same question. Okay, back in the back. Is there a way to label specific intersection points between the 80% and the 20%? Is that what you're asking? Oh, between those and the trend line, or between those and our line. There's really not. However, I can find a link, and I'm going to risk going out to the internet. We know it's a little bit slow. If I go to... You can add an annotation, and you might be able to drop some fields into that annotation that would be dynamic as things moved. Okay, I'm just going to close that. And let's try, there we go. If you are interested in looking at that 80-20% in a little bit more detail, you can do something like this. This is a wonderful Pareto chart where it will actually break down the aggregate value, and it has a label down here to show you 23.9% is what's driving that 80%. and then it breaks down all of the detailed data. And then if I go to details, I see the granular data inside of each of those detail categories. So there are ways that you can start to get to more granular data. You might also look into dual axis charts and things like that to extract that value, but there's no right click and add that point. Any other questions? One more question, yes?
So, Pareto chart relies on sorting, right? Greatest, largest, smallest. I didn't hear you say, maybe I missed it, but I didn't hear you say sorting. So,
Right at the very beginning, let me build a new worksheet.
is there a default, or did you?
The default sort on desktop, oh, that's a new dashboard. The default sort in desktop is alphanumeric. But what we want to do is look at our number of records on rows, our complaint type on columns. The first thing we do is sort in descending order and then change our fit to entire view. When I copy my complaint type field as a discrete dimension to detail, we are actually running our table calculation along the sorted complaint type field. It's one of the reasons why you control, click, and drag is you manipulate a field. In this case, I manipulated complaint type to sort it, so I have that sort icon. After you finish your manipulation, you drag that field and copy it wherever you need it in Tableau. So number one, you don't have to recreate anything. Number two, if you do recreate something, you don't do it the wrong way or a different way than you did before. All right, we have just enough time for Christy to cover one last thing, hex bins.
Thanks, Laura. Testing. Oh, better get him from the speaker. Good? All right, thanks, Laura. All right, hex bins. Who's heard of them? Who's done them? Okay, for those of you that have not heard of them, that's a hex bin. Okay? What we're doing is this. When I am hex binning data, the reason we do this is I have really dense data. So I just moved to Washington, D.C. Back in February from Austin, Texas. And I must admit, my Texas mom was quite worried about the crime rates in that area.
You might want to close the caption.
Oh, thank you. We have a caption open. So what she wanted to do was kind of find out where crimes were happening in that area. So if we were just to take a look at this hex bin information or the non-hex bin information, but if we were to bring out our X and our Y axes, which are our latitude and our longitude, not our number of records, then I get that one little dot showing me where crime might be. I'm going to use something like number of records on size so we can see how many crimes there are. And from here, which by the way, this includes all crime, not just serious crime. And then I can take things like various different blocks. And with these different blocks, I can go through and see, or let's do object ID, exactly where each of those crimes occurred. Now here's the problem. What are the chances that only one crime happened right there? Okay? Or can I tell if 1,000 happened here or if 50 did? Once you get to a certain level of data density, there's so much overlap that you can't tell what's happening. And that's what hex bins seek to solve. Because we can use other fields, like I might take something out instead of this dimension of object ID, which breaks my data apart. I could take voting precinct and set that over here on detail, so I get a dot for each voting precinct. But depending on the shapes of those different regions, I might have a bubble that's pulled things from really far away on in. So it distorts the shape of where those things are happening. So if we want to see exactly where everything is occurring, one of the things we don't want to do is aggregate our X and our Y, or our latitude and longitude. So if I clear this worksheet out, and instead of dragging those in aggregated, let me rephrase because I am terrible about remembering which column X and Y go on. Just double click for latitude and longitude. They go to the right spot all by themselves. If I switch this out to my dimensions, notice that it's instantly showing me every single spot that I have data happening. So by changing these to dimensions, I can now find out how many things happened in one spot. Again, it's still too dense because I can't tell how much overlap there is. But the fact that I'm not aggregating this information means I'm not pulling it in any direction. This concept is the basic of hex binning, because what hex binning does is it comes through and it finds a center point, and it counts how many number of records there are within that physical space. Okay? So where if I came through and used a different field to aggregate that data and get that average, it's moving those dots from where they actually occurred into where that central point is. And my mom would not be happy with those results. So by leaving this with X and Y, I can actually go through and with hex binning count where those things actually happen. That's all hex binning does, is it says find that center point, then based on our X and our Y, find out where these things happen. So the hex bin itself is fairly simple. I'm not going to go into too much detail on it because, again, we don't have more than a minute, but we just have these very simple formulas. It's our X and our Y value. That scale factor just says how many hex bins to put in per each latitude and longitude change. And so if I use those hex bin formulas and just double click and paste those on up, I'm going to be able to get my hex bin information. And by using them as dimensions, I can lay those out where they belong on that geographical space. And something like number of records is counting or binning that information underneath. And I can see where that density actually exists. Doesn't have to be a map. You can use a scatter plot as well. So that takes us right up. I think I've got 30 seconds left to wrap up. Thank you all very much for coming out. If you're interested in other sessions related to this slide's also available on the downloads, and I will request that you please take the time to give us some feedback. We are doing this session again. We'd like to make it better. Let us know what we can do, and thank you all very much for your time.